Okay, everyone, we're going to reduce that diabetes. Actually, you're reducing the sugars of the diabetes. Well, I don't know if the sugar diabetes, but regardless, I'm doing this right after Halloween. So you're eating all that candy. You went out, your young kids got a bunch of candy, and now you're diabetic because you're eating all the, what is it, the Tootsie Rolls and the, what's your favorite candy? Twix. And my favorite's the one with the M&Ms, but with peanuts. Really like those. Very bad for you. So this is why America. So a goal here is we ate too much of that Halloween candy. Our sugars are high. Let's decrease the diabetes. So let's just consider this treatment. So on the quiz, opposed to having the Excel sheet, you're going to have, let's take a look. You're going to have to copy and paste like I just did right here. Okay, so you copy and paste it. So here it is. The control group, CONT, is basically a group that does not get, like I've said a number of times, that does not get the experiment. So you're not getting medications nor diet. The med group is a different group of people that have decided to participate in this very cruel study, and they get just meds. These people, MD, they're not medical doctors, but they get medical drugs and diet. So these just get the med, these get the med and the diet, and the control group gets nothing. So let's call it something to make it a vector. And my argument is treatment, because then we're going to quickly do it. So you're going to make it a vector. All right, but this time you should be knowing how to make a vector. So we got it. And you can literally see it. You can do head. And that will do the first 6 points, I want to say. Let's take a look. Treatment. Now, you don't have to do that, but yeah, it's the first 1, 2, 3, 1, 2, 3. And then you could do tail, which is the last points in the data set. Or I'm sorry, the vector here. Boom. You get the MDs. The MEDs didn't come out because they're in the middle, but you could also do length. You don't have to do this. This is just showing you, treatment. Right here, treatment. Boom. So there's 25 points, right? Pieces of data. So that's what we're doing. Now you've got up here, right? I give you, say, the sugars on a quiz. So sugars, that's the individual sugars of the people. Now they match perfectly. So like when you do it, this first control is 81, this control is 89, this one, matches. It goes in an order, okay? So I'll call it sugar. Right? Very nice. Very nice to call a person sugar like a partner, but it's actually bad because that kills you. So sometimes our partners kill us. Let's take a look. All right, it works. So now this is the steps we do. So this is a pretty easy study. Now, this is what they really do in medicine. They do experiment and control groups. The experimental groups get whatever you're giving them. It could be, say, for example, a COVID. This could be instead like the control group doesn't get anything. The second group gets the COVID vaccine, right? And the second group gets vaccine and the booster. So then you see if they're more likely to contract COVID. Of course, if they get the vaccine, then you can track the people forever because we know that there are some kind of chips in that vaccine that tracks you. So anyways, the point is that in this case, we're doing diabetes. So these are the sugars and that matches up here, the treatment. So all you're going to do is put it together with the AOV function. That's ANOVA to see if there's variance between these two groups, to see if these meds and diet are doing anything in comparison to the control group. So let's call it something. What are we going to call it? Let's call it, Halloween. Halloween. Is that how you spell it? All right, because you're going to get diabetes after you do all that stuff. So, okay, here it is, Halloween. So remember the dependent variable is what we're measuring, and that's the sugars, right? So let's take a look at sugar. See, it comes right up. And then let's do the T tilde because we're running regression. And then we have the treatment. That's the treatment group, basically. People who are getting it, people who are not getting it, like that is the meds and the medical meds plus diet, and then the control group is to kind of compare those other groups. Because if you're not getting anything, I mean, theoretically speaking, your sugar should stay the same. So we're going to see if there's any difference here. So let's do a summary of Halloween. All right, see if that Halloween candy is killing us, which we know it is. And when my kids come to my house for Halloween, I teach them statistics, and they don't like that. All right, so a big something's going on here. There is a big difference between these groups. Notice there's only 2 treatments in that because degrees of freedom, which we'll get into. But look at this. So what makes your data good if you want to see it? The higher, the better for this first line. The higher sum of squares, right? The higher this mean sums of squares, and then the higher the F value, like we did T values, Z value, etc., the better for your model, because the more likely you're going to have a significance. The lower the residuals, the better. That's very important to understand. We're going to show you again in another video on why that's important. So basically, that's what you have to know now. So anything with the word residual errors, the lower the better. You don't have to be a statistician to get that. And we're running it. So like if we were real medical scientists, which I am, I'm actually a real doctor, right? Medical doctor, not, the difference is negligible. I can still prescribe medicine, I think. Well, I do. I don't know if it's legal. But the thing is that here you go. So take a look. You've got a significance. That means there's a significance difference between some of these groups. Which ones? That, my friends, is the question. Which one? And that's what we are going to see now. So how do you see that? How do you see that? Well, you do it. Sorry, my mic moved. By the Tukey test. So there is a significance here, right? It's pretty good. Tukey. So you just go T-U-K, Tukey, HST. I say turkey, LSD. All right, we're coming up to Thanksgiving, so that's very important. And now let's take a look at what's going on. So we take Halloween, right? Boom. So this is what we're seeing. So we're seeing a big significance over here between meds and diet and the control group. So there's 3 groups. I'll just quickly write them here and then get rid of them. You have a control group, right? And then you have an meds group. Let's just call it meds, right? They're getting just meds. Oh man, I hate that pop-up thing. And then you're getting the third group, MD, which is meds. You're getting the medical, the meds. I say meds like, their medicine, and the diet. So it seems like here, the people who are getting the meds and the diet versus the control group getting nothing, they get nothing, is significant. And then you go down here, the meds and the MD is significant. But notice the meds and the control group, meaning if you're just taking meds, there is not a significant difference between just not doing anything and taking meds. Sorry, pharmaceutical companies, you didn't pay me enough to fudge the data. So meds alone would cure your diabetes. So you're basically saying to yourself, right, there's a control group, it gets nothing, right? These are the people in one group who get nothing and they have high sugars. Then you have another group, the people who, and then these people are going to get meds, that is the pills, whatever the diabetes pills, the diabetes medicine, and that's the second group. Then you get the third group that gets the same pills, and in addition to that, they diet. So it seems to be saying that the best group is the meds, that they get the pills and they diet. The people alone, right, that get the medicine don't seem to be doing that much because it's not significant. Remember, significance anything under 0.05. There is no diet, just diet. And against the control group, that would be cool too, because we could have a fourth group, but we don't have it. But that's not important now. The point is that's what it looks like. Now, how else can you change this around? Well, I wanted to do it rather quickly. I don't want to go. This is GGplot, right? And I put it, it says sugars. So you're going to have to, I'll have to change that. And this should be like this. So let's take a look. So GGplot. Notice there's nothing in here. Usually there we put the name of the data set, but there is no data set. So you'll have to be able to know that. Then we've got sugar, but it's actually sugars. I just wrote that in there because I wasn't sure what I said. And then you've got treatment as X because that's, and then you've got GM boxplot. Remember, we've done other things. So then I'm filling it because there's 3, pink, purple, and blue. What do you people think? And then you come over here and look at, this is where it is. And this is, look at the meds is okay, but the real decrease is here. And this is really interesting. So you look at it here. I'm going to GGplot it. I'll have to put, remember, when you do the GGplotly, anything you're doing, the goal of to understand coding is everything has to go into the parentheses. It's like a command. So GGplotly, right? Do that. Remember, you have to get this out of the library first. Ooh, I hope I did that. And then you go here, you gotta. So here, now it's interactive. Interactive means you can look at, you can see the thing. So this is interesting. So this control group is still pretty high. The meds, only meds, is basically coming down a bit because, you know, you look at that median, but not that much. And this becomes problematic. And then you've got this is coming down really low because it between there, and that's the midpoint. So I'm sorry, the median. And you basically are saying, yeah, that's the max, obviously. So it's coming down. So that is an interactive plot. What I just realized, and I don't like, which maybe I won't ask that question then on a quiz. Let's get rid of GGplot and just do GGplotly and just do GGplot. Ready? It is showing that as an outlier. So if I do ask that as a question, do it as GGplot, not GGplotly first, and I'll make that clear. You know, don't use GGplotly because I don't know why this went up here, probably to make it interactive, but then you lose the outlier point. So I get it because it makes the line here, and that was like just made the line. Interesting. So anyways, regardless, is you see the pink is the control group. That's still very high. You see the MD, that's getting really lower. And that's why it's statistically significant. And then you see the meds, which isn't moving too much, but it is, if you notice the point that's up here, it is getting a little lower, but not statistically significant. And that's what you have to ask yourself sometimes. Just because something is statistically significant, it still is, it seems here to be a little better, but not much. And then this one really dives. And that's why the med MD, which is here, and the meds is statistically significant at 0.026. Not much under 0.05, but still significant. And then you look at the MD versus the control group, that's very significant. Look at an extra 0.0020. And that's very significant under 0.05. They don't usually say very significant, but you get the point. So the MD compared to this. So these are being compared. MD versus the control group. MD versus control group is significant. Meds versus control group, meds versus this group, this blue group versus pink. Not very significant, and you see why. It doesn't seem to be moving too much down. And then the meds versus the MD, the meds versus this, you see it is coming down significantly. So that's the goal of the box plot, which is pretty good. I know we can do, I might as well do it since I'm on. I want to ask you to do, it's the jitter. I don't really like it, but we'll take a look. In some cases I do. Let's see, GM jitter. See if it comes out pretty good. Nope, it did come up anyways. Let's take a look if we were able to do this. And because I filled it, and you can't really fill things. So if we just do this. It did come up. Would have to different colors, but this is the control group. You see the specific points. And then these are the meds. That's a little different. I think if you just do color, let's see if that works. I don't usually use jitter, but you know, someone might like it. We can do 3 colors. Here, we'll just do the same colors. I'll just copy and paste here. That's one of the things about coding. People, you know, someone asked me, a professor once, I was teaching it, and he said, can you just copy and paste? I'm like, yeah, that's all. No, it didn't work. So how would we get those to be colors? What else would you do? Because the black is kind of boring. I'll have to figure that out because that doesn't make sense to me that you can't do unless you fill it. Let's see if we can fill it. Fill it with sugar, which will make it nice and sweet. And I didn't do it. But anyways, the point is that that's called the jitter plot. You can make it colors, but I'll have to figure out how. I don't really use it. But the point is that it's a very important test. Nope. For to do. So you basically want to know because that jitter is kind of ugly from my point of view. Just doing it like with the black. I'll have to do it. So I prefer the box plot. Go back to that. So the GG box plot, I think, is a little more aesthetically good looking, but that depends on where one sits. So thanks for coming out, everyone. And that is very important research. And if you are able to do this, that's awesome because a lot of people, even in, PhD programs, can't and don't do this. So you should be very proud of yourself if you're able to pass this quiz, and that is on your own. Okay, take care, everyone.